does it actually take to move real sensor data from FPGA fabric through DMA and memory across Linux and into a GPU-based AI system? Well, most courses teach the individual pieces. Very few show the complete end-to-end pipeline working on real hardware. And what you can see here is shows the sensor, PL, DMA, DDR, CPU, UDP, Jetson flow. And this is going to go from the Kria to the Jetson Orin. And this here is the single sensor for now. And so that is a BNO055 IMU. And so you see it's sending the data into the FPGA. And this program is what is inside the Pico. So this one is the MicroPython, and it packetizes that IMU data, sends it in, and there was the value on the Kria in the Linux system. And what you see now is after it went through the Ethernet in UDP format, and it still is now, it's being displayed in real time, the data, the quant data, and then it's also translated into XYZ data. So again, in this block diagram, you could see that the sensor data is going into the FPGA, and then that makes its way up to the user space in the Linux, and then sent over to the Jetson Orin Nano. This is what you would see in Vivado. This is the whole hardware design. So it uses the Zinc and a DMA engine. And this here is showing just the bare metal application. So I'm on Vitis on the right, and that I'm stepping through, and then I'll just do a run. And when it runs, it's going to keep just getting data, and you can see the packetized data on the right. And on the left is Stoney, and it's showing the data that it's sending over before it's put into 32-bit format. And so it has a header, so it's able to sync up, and has a checksum. And so all of this makes it possible to have reliable data. And so you get deterministic behavior capture on the FPGA fabric, and this whole system is in the